look at quadratic equations in more detail. We've already had the opportunity to look at how to solve quadratic equations by factoring. Well, today our focus will switch to primarily situations where quadratics will not factor. And we're going to look at some different strategies that we can use to solve this type of equation. Alright, so let's get started. So the first thing I want to look at is, what if we were presented a quadratic that it was in vertex form? So let's have a look. I got a couple of examples here. So if I looked at this first one here, x subtract 3 in brackets squared minus 25 equals 0. I looked at, well, what can I do to solve that? Well, at this point, your first reaction may be, well, why don't we expand it out and make it look like see if it's one of our factoring strategies. So let's try that. So let's take, so square this binomial, x squared, subtract 6x, so multiply and double, square the last one, take away 25, is equal to 0. X squared, subtract 6x, subtract 16, equals 0. Are there any two numbers that multiply to give negative 16 and add to give minus 6? Yes, there are. So this does factor. X minus 8, x plus 2. Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6, giving us two possible solutions, x equals 8, or x could be negative 2. So this would be relying upon our ability to expand, which we have that skill set, then tidying things up and seeing if it fits one of our factoring patterns, which this one did. It was a simple trinomial and it did factor, so I used that strategy, and there would be absolutely nothing wrong with doing it that way. However, the fact that it's in vertex form can lead to an alternate solution, which you may find a little bit quicker. And the alternate solution is to do this. Isolate the part that's being squared. So for example, now this only works if it's in vertex form. That's really, really important. It has to be in this form. And the part being squared is this. So I'm going to isolate that. So it's going to be x take away 3 squared. I'm going to move the 25 back over. So this goes away from our strategies that we use here where we always want it to be equal to 0. Now, once you do this, what you're going to do is take the square root of both sides. Now, the square root of anything squared is just going to give you that binomial by itself, x subtract 3. Now, this is the key. When you take the square root of the right side, you have to make sure that you put down that the square root of 25, just quickly have a look at it here. Of course, your first reaction is say, well, that's easy, it's 5. And I say, well, why is it 5? And the students would respond, well, the reason it's 5 is because 5 multiplied by itself gives you 25. Well, then I would say, well, how come could it not be negative 5? Based on definition of, because 5 times 5, 25. But wouldn't negative 5 multiplied by negative 5 also give us 25? And the answer is yes. Now the number 5 here is what we call the principal square root. This negative 5 only becomes an issue when you're trying to solve for an unknown. So in this case, I'm trying to solve for x. If I just do principal square root and do 5, well, all of a sudden this equation, which we know has two answers, is going to appear that it only has one answer. However, if you put the two possibilities here, the plus or minus 5, now all of a sudden we're going to get both answers, and I'll show you how. So all you're going to do now is, once you get rid of this squared, you're going to isolate the variable and get it by itself. So x equals, you're going to take that negative 3 and move it to the other side. Generally, you'll see that it's always going to be written first, then put your plus or minus 5. And now, what this means is you're going to do 3 plus 5 and get one answer. Well, 3 plus 5 is 8. Look at that, there's one answer. The other answer will be 3 take away 5. That's what this plus or minus means. You do 3 plus 5 to get one answer, you do 3 subtract 5 to get the other answer. 3 subtract 5 would be negative 2. Look at that. Same two answers. That's using an alternate strategy. It's where you just take the square root of both sides to eliminate your squared. Now again, this only works. Neat solution, but it only works if your equation is presented in vertex form. Let's take this second one here, and I won't do it both ways. I'll do it just by isolating. Oops. So I'm just gonna I think we'll take it to a clean page here. Paste that here. All right. So I notice this is in vertex form. It only has the single x here inside this bracket. So when you see that, that's going to be your opportunity to isolate. Negative 3x plus 1 all squared. Bring your 48 to the other side. Divide by this coefficient, negative 3. Divide this side by negative 3. Now you have to be careful. What sometimes students will do is they try and take the square root too early. You have to wait until you get this, whatever's in brackets here, squared. Now you may have just an x squared. Well, then this method works as well, as long as you don't have an x term there. What I mean, but so if I had 3x squared plus, I don't want to use plus, let's go minus 27 equals 0. Well, I just have this single x squared. I could solve this the same way. I don't have to factor it if I don't want to. Take that over there, divide by 3, divide by 3. X squared would be 9. And then when I take the square root of both sides, x would be plus or minus 3. However, if this equation had been 3x squared minus x minus 27 equals 0, this strategy will not work because I can't isolate the squared because there's still going to be an x here that when I move it over, there's going to be an x on the other side. Whereas here, the only variable, I was able to isolate it by itself. The only variable is here. We try and isolate it by itself. All right, so negative 48 divided by negative 3 is 16. Take the square root of both sides. We're going to get x plus 1 plus or minus 4. Remember, you need the plus or minus because you're trying to solve for an unknown, and you need to be able to get your all possible solutions. If you just do principal square root, you will only get one answer. So now isolate the x. So that means you're going to bring that plus 1 over to give you a negative 1 plus or minus 4. And now you get your two answers. Negative 1 plus 4, 3. Or negative 1 take away 4, negative 5. So that would be your two possible answers, 3 or negative 5. You could expand this all out, set it equal to 0 and solve, and you would obviously be able to factor it because you can tell by the types of answers you're getting that it would factor. But that's just an alternate strategy to use when there's just the single variable squared, whether it's in a bracket or it's just like this one over here, it's just an x squared. You can isolate it, take the square root of both sides, and then just make sure you put your plus or minus here, and that will lead you to both solutions as well. So that's a good strategy to have in your arsenal of solving for when you get to certain types of equations. Okay, so what if you were presented with this quadratic, x squared plus 4x equals negative 1, and I asked you to solve it. So you say, oh, I know how to do that. He said make it equal to 0, which you did. But then here's your dilemma. It doesn't factor. Well, if it doesn't factor, obviously our factoring skill sets are not going to help us. It says here, maybe if we put it in vertex form, that would help. So let's have a look at that. What if I switch this to vertex form? So I'm just going to take x squared. So you got to remember to do that from our first section of the course, which was on quadratic functions. So I'm just going to put plus, leave some room. Got my minus 1. Oh, better leave some more room there. Complete the square and then balance it out here. Okay, so let's switch colors. So take half of 4, which would be 2, and square it. There's no coefficient here, so I added 4. I'm going to take away 4 here. Put my equal 0 back in here. Now I'm going to complete the square on this and factor it. So it's square root of the first, sine of the middle, square root of that one, all squared. -1 take away 4 is -5. So now I'm in vertex form. So let's use the strategy we just were shown. Isolate this. So x plus 2 all squared is equal to 5. Take the square root of both sides. Now here's the difference. In our 2 prior examples, this number was a perfect square, so I could easily take the square root of it. In these ones, that number's not going to be a perfect square. That's dead giveaway, it doesn't factor. So that tells me I'm on the right track because this won't factor, so factoring skills aren't going to help me. Whereas the last 2, when I got to here and saw that this was a perfect square, that's an indicator that it would have actually factored. Square root of the left side. And all you're going to do here is just put plus or minus square root 5. And you're not going to take your calculator unless we needed if it said find the solution correct to the nearest 10th or 100th, yes, I'd take my calculator and figure this out. But for solving purposes, we're going to get exact. Exact means we leave this as just a radical. Now all I'm going to do is take my 2 to the other side, -2, leave my plus or minus, radical 5. And there's my 2 answers. So this quadratic has 2 solutions. One of them is -2 plus the square root of 5, and the other one is -2 subtract the square root of 5. So there is a strategy that we can use to solve quadratic equations that do not factor. Good news is this strategy works even if they do factor. You could do every quadratic this way. Now, I don't recommend that because if you're good at factoring can obviously be quicker than that. That takes a little bit of time. But this is a strategy that would work every single time, even if it did factor. And we'll look at that eventually and say, well, how do I know if it would or wouldn't factor? 4x squared, take away 8x, take away 3, equals 0. Let's suppose I try and factor. 4 times -3 is -12. I want to multiply to get -12 and add to give a -8. Well, sometimes students say, well, -6 and -2. They won't work because they multiply to give a +12. So if you try all the possibilities to multiply and get -12, there are none that add to -8. Doesn't factor. All right, I'm going to go to completing the square then as my new strategy. Now this one's got a coefficient, so I'm going to factor it out. 4x squared. Take away 2x plus, or minus 3. Remember, we got to put a number there, so I'm just going to leave a bit of room. Equals 0. Take half of 2, which would be 1. Square 1, you're going to get 1. Now remember, if you put a number here and there's a coefficient, when you go to balance this out, you've got to multiply these. 1 times 4 is 4, which means it's a +4. So to offset that, I'm going to take away 4 here on the left side. 4. Square root of the first, sine of the middle, square root of this one, all squared. -3 take away 4 is -7, equals 0. I've got a single variable now that I can isolate. X take away 1 squared, so we're going to move that over there to give us 7. We're going to divide by 4, and again, if these don't go evenly, that's fine, just leave it as a fraction. Don't get into decimals, unless you have to. Our goal as students in pre-calculus and calculus is to avoid touching calculators unless it's absolutely necessary. As I've stated probably in some other videos, most of our introductory calculus programs beyond high school are often presented to students where they're not even allowed to have calculators anywhere near them. So the sooner we get more comfortable dealing with situations and not relying on the calculator, the better off you're going to be. So when I get to here, I don't care what 7/4 is as a decimal. I'm just going to take the square root of the left side and the square root of the right side. Now the square root of anything squared is just that binomial, x minus 1. Now when you take the square root of a fraction, you need to realize that it's the square root of the numerator and then the square root of the denominator. The fact that the denominator is a perfect square will allow me to write this as, remember, it's always plus or minus the square root of the numerator. If the bottom is a perfect square, take the square root of it. So notice the radical's only on the numerator now, not on the denominator, because I did the square root of 4, and I got 2. One step away from getting our answer. X would be, bring your negative 1 over and you get a positive 1, plus or minus the square root of 7 over 2. And we'll get an answer here of x equals 1 plus or minus, oops, I want to show you the two answers. So the two answers, one of them is plus, right? So 1 plus the square root of 7 over 2, or 1 subtract the square root of 7 over 2. And these will be what we would classify as, in both examples, exact solutions. Now, unfortunately, we're at this point relying upon your grade 10 knowledge of radicals, which is quite limited. We haven't got you to do too much with radicals in grade 10. Following this unit, we will do a section or a part of a unit on radicals, so we'll get a much better understanding of square roots and cube roots and that type of thing. So we'll try and keep it pretty basic at this point in terms of radicals and what we expect you to do. But there will be situations where these radicals will reduce. And again, we'll get into more details as we do a unit on radicals. But anytime a square root is not a perfect square, it's said to be irrational. If you remember that term, grade 10. But irrational means non-terminating, meaning never ends, and non-repeating. Every non-perfect square is irrational, which means that if you put this in your calculator, you could round it off to a couple of decimals and give me really, really good estimates, but they would be nothing more than estimates. By leaving it as radicals, these are now exact solutions. So anytime you're reading a question that says determine the exact solutions of the following, that is indirectly telling you do not put the radicals in your calculator. If they want you to if they wanted you to get these to be decimals, the instructions would say, and you'll see an example or two here later, determine the solutions to the following quadratic to the nearest tenth. Then I want you to put this in your calculator and give me the answer to one decimal place. Otherwise, we leave them as radicals. And that's easier for us too, so that's good news. All right, so on we go to have a look at a couple more. All right, so if I look at the first example here, I see a quadratic. Now, one thing I'm going to recommend that you do is anytime you go to solve a quadratic, your x squared term, so this one, it will be in your best interest to always have that as a positive. Now you may say, well, how can I control that? Well, it's easy to fix. So there's two ways. You can either, as soon as I see a negative 3x squared and I have my equal sign here, just move these terms this way, have your 0 equals over here, or I'll show you both. So do it this way, go, this is negative, so what I'm going to do is move everything from the left side, so that'll switch my x squared to positive. That'll go there. This is going to stay where it is, so it's minus 1. Or, some people like to just always move everything to the left, so plus 5x plus 1 equals 0. And then when you get here and you notice, oh no, I've got a negative in front of my x squared, and I'm not saying you can't solve it this way, but I'm going to tell you over the years of watching students work their way through these, a lot of mistakes are made when that number in front of the x squared is left as a negative. So we say, well, how else could I fix it? You could just take both sides of the equation. As long as you multiply both sides by the same thing, your equation will still be equal to. So you multiply the left side by negative 1. The right side, because it's 0 times negative 1, is going to stay negative 1 anyway. So it just becomes 3x squared, subtract 5x, subtract 1 equals 0. Notice, same thing as this one. All right, so now we're going to try and solve this equation. 3 times negative 1, so it's a hard trinomial, negative 3. No way to multiply to get negative 3, add to get minus 5. Now this one's going to be a bit uglier because we're going to have a lot of fractions on the go, but we're going to expect that of you in a pre-calc course. So here we go. Let's see what we can do with this. Actually, no, I'm going to put the 0 on the other side. So let's take out our 3, x squared. We've done this before. It doesn't go evenly, just leave it as a fraction. 5/3 of x plus minus 1, leave room, equals 0. Now, half of 5/3. Half of means to multiply. Half of 5/3 would be 5/6. Well, you take half of this and square it. So when you square a fraction, you square the numerator and you square the denominator. Now, this 25 over 36 is going to get multiplied by this 3. So I'm going to figure out what that's equal to. 25 over 36 multiplied by 3 over 1 is 75 over 36, or you can notice and say, well, 3 will divide in, because this is multiplying, 3 will divide into 36 12 times. 3, divide both of these by 3, and you're left with 25 over 12, which is just the reduced version of 75 over 36. Now, that means I've added either if you go the non-reduced version to be 75 over 36, or the reduced version, which is 25 over 12, which means I'm going to have to subtract 25 over 12. Okay, let's see what we've got now. Leave your coefficient, square root of the first, sine of the middle, square root of your third term, in bracket squared. 1 over 1 is 12 over 12. Take away 25 over 12, that's going to give me negative 37 over 12 equals 0. Now we're going to isolate. We want to get this part here, the part that's being squared, with the single x in the bracket, isolated. So one step at a time. As you get more comfortable with it, you might be able to do a couple of things at once. But for now, I'll just move one thing at a time. So that's going to go over here. It'll switch to positive. I want to get rid of this 3 out in front, which means I'm going to divide by 3. Now, when you've got a fraction on the go over here already, think of dividing by 3. It's the same thing as multiplying by 1/3. So imagine that I put a 1/3 in front of here. 1/3 and the 3, then those 3's cross each other out. Whatever you do there. So multiplying by 1/3 is the same as dividing by 3. Now we're down to x, take away 5/6, all squared, 37 over 36. Now, just because the fractions get introduced and the numbers get a bit uglier here, it doesn't mean we change our strategy at all. We just keep following through. So the next thing we did earlier on is we took the square root of both sides. And that led us to, in this case, it would be x subtract 5/6 plus or minus. Now remember, if it's a fraction, now if neither of these are perfect squares, for right now in your radical experience, just leave it as a fraction. But because the bottom number is a perfect square, I'm going to actually take the square root of it. So I'll leave the top one under the radical, but I'm going to do the square root of 36 and change it to a 6. Okay, we're almost there. I'm going to go here, x equals, take our negative 5/6 to the other side, so 5/6 plus or minus the square root of 37 over 6. Now, because these are already common denominators, you may want to, here, you may want to write it as a single, so x could be written like this. X equals 5 plus or minus the square root of 37 all over 6. So then there's two possible answers. 5 plus the square root of 37, divide that by 6 will give you one answer. 5 subtract the square root of 37 divided by 6 would give you the second answer. If you leave it like this, your solutions are exact. personally, I don't really care whether you can stop here or go to here. What I want you to be able to do is if you stop here and you turn to an answer key and see this as the answer key, I want you to realize that these are the same thing. All right, we got one more here. Let's have a look at where this one goes. So this one, same idea. Let's set it equal to 0 and see what happens. 2x squared. Always pull your x squared, your x, and then your number. Now, this one actually factors because 2 times -3 is -6, and I want to get a -5 as my middle term, so I could use -6 and +1. But I'm going to assume that I didn't notice that, and I'm going to show you that it still works. I'm going to do this one by completing the square. So we're going to go 2x squared, take away. You've got to take the 2 out of the middle term as well. Got your -3. Remember, you're going to complete the square, so leave a bit of room. Half of 5 over 2 is 5 over 4. Square that, you're going to get 25 over 16. That number gets multiplied by 2. 25 over 16 times 2 over 1 is 50 over 8, which reduces to 25 over 8, which you could do right away here by saying, I'll divide both the numerator and denominators here by 2. Oops, that'll give me a 1 here, and that'll give me an 8 here. So there is 25 over 16 multiplied by 2. So I want to put the opposite here, which would be -25 over 8. All right, 2, square root of the first, sine from the middle, square root of that. This one's going to be 5, or square root of your third term, 5 over 4, all squared. Okay, some fraction work, 3 over 1. This one's over 8, so common denominator, I would want this to be an 8, which means I'd have to multiply the numerator by 8. -24 over 8 minus 25 over 8, that's a -49 over 8 equals 0. I want to isolate now. I want to get to the x minus 5/4 squared by itself. 2x take away 5 over 4 all squared. Bring your 49 over 8 to the other side. There we go. I want to get rid of the 2, so I'm going to multiply by 1/2. Multiply the other side by 1/2. That will lead us to x. This other side will be 49 over 16. Take the square root of both sides. Get rid of your squared here. Square root. Now notice the difference this time. Even though it's a fraction, but both the numerator and denominator are perfect squares. X minus 5/4. So certainly we wouldn't leave it like this. We would take the square root of the numerator. Don't forget we're going to go plus or minus. Square root of the numerator is 7. Square root of the denominator is 4. So as soon as this happens right here, this is a dead giveaway that it would factor. So how do I know that? The way you know is when you're dealing with a perfect square here, whether it's a fraction or just a single perfect square. So as soon as this fraction has this perfect square in the numerator, perfect square here, you could have factored it. Now that doesn't mean you go back and start over and factor it, because you're 10 seconds away from having the answers. But there may have been a quicker way is all it means. So 5/4 plus or minus 7/4. So x would be 5 plus 7, 12 over 4, which is 3. X equals 3. Or 5 take away 7, which would be -2 over 4, and that reduces to -1/2. So let's go back and look at the original question. The original question, once we got it set equal to 0, was 2x squared minus 5x minus 3 equals 0. I'm just going to jot that down here. 2x squared minus 5x, take away 3 equals 0. So we would hope that our good quality pre-calc students would look here, and before they ever get into this, not because we can't do this, but because there's a saying, work smart, not hard. It's quicker and easier to look at this and say 2 multiplied by -3 is -6. I do know two numbers that multiply to give that and add to give that. They are -6 and -1. So use your factoring strategy instead. 2x subtract 6, 2x plus 1. Divide this one by 2. X take away 3. 2x plus 1 equals 0. X could be 3 or x could be -1/2. If you recall, doing all that work I did over here, see if I can put the two kind of side by side. Look at it, view full screen here. So here's the work. That's not what I wanted. There we go. This was factoring. And this was using completing the square and putting it in vertex form. You'd be hard-pressed to make the argument that this method over here was any easier. This certainly is more efficient, meaning I can do it quicker, and I think that the process to get to here is much easier. So that's why we would always recommend, when you're trying to solve a quadratic equation, the very first thing you try and do is factor. It is the quickest and most efficient way to solve an equation usually, unless it was already in vertex form. So maybe if this was already presented in this form, and you didn't have to do the work to get it to vertex form, well then maybe you would do it by isolating and square rooting both sides. Alright, so let's get back to our slides. Those are just on vertex form, but I'll put those up later on. Well, here is now the final way that we will solve quadratic equations. So you'll see here shortcut alert. Now, it's still not shorter than factoring. Factoring is still the most efficient way. This is probably, though, much more efficient than completing the square. And basically what it does is it takes the steps in completing the square and turns them into a formula. And that formula is referred to as the quadratic formula. So what I'm going to do is show you the formula, then I'm going to show you where it came from, and then I'm going to show you how to use it. So this is the quadratic formula. You absolutely need to know this. First thing you want to do to use this formula is you want to get your quadratic in this form. You want your x squared, your x term, and your number, and you want it equal to 0. So you have to expand, collect, move things around so that it ends up looking like this. A can't be 0. If A was 0, this would be linear. We wouldn't be getting into this at all. A is always your coefficient of the x squared, B is your coefficient of the x, and C is your numerical term here, including the sign in front of them. So for example, if I had 3x squared minus 4x minus 2 equals 0. A would be 3, B would be minus 4, and C would be -2. And I would take those three numbers and fill them in this formula wherever there's an A, B, and C. So A goes here and here, I'd fill in the number 3. B is -4, I'd fill in -4 there, and C is -2, I would fill in -2 there. And that would give me my solutions. So this is the quadratic formula. As I said, make sure at this point you've paused the video and you've got this written down. You absolutely need to have that formula memorized. It's not given, you need to know how to use it, which is where we're headed next. Now, before we get to how to use it, I'm going to show you where the formula came from, just the math behind it. Not that I'd ever ask you to do this, but I don't generally like to just throw formulas out there and say, here's a formula, use it. I like to show students the math behind it, especially when we get to pre-calc courses. So what would have happened is many years ago, mathematicians would have been solving quadratic equations, most likely by completing the square first, And then somebody would have noticed and said, we seem to be doing the same steps over and over. Well, anytime you're doing the same steps repeatedly in mathematics, you can always turn that into a formula. So what they would have done is said, well, why don't we generalize, and rather than put numbers here, we'll use variables. So a will be in front of the x squared, b will be in front of the x, and c will be here. And let's solve this quadratic by completing the square and see what happens. Well, that's what I'm going to do. So I'm going to complete the square. I'm going to factor out the a. Imagine that this a is just a number. So if that was a 2, you would just divide this by that number. So that's going to become b over a, x, plus, leave room, plus c, equals 0. Now I need to take half of this. So half of b over a is b over 2a. Well, then I'm going to square this fraction. So you square the numerator, and then you square the bottom. You got to square the 2 and square the a. So that's going to become 4a squared. Well, there's half the middle term squared. That's what's going here. b squared over 4a squared. Then I'm going to take that and multiply it by the coefficient. Well, let's figure out what I get when I take b squared over a squared and I multiply by an a. Well, I'm going to get ab squared over 4a squared. Well, then this a, we'll get rid of one of these a's, and we'll be left with b squared over 4a. So this multiplied by this would be b squared over 4a. So that's what I'm going to have to subtract here. Oops. Subtract b squared over 4a. Remember, the c is over 1. All right. Now, when we were doing this with numbers, we just left this square root of the first, sine of the middle, square root of this one. Now, these are both perfect squares, so the square root of the numerator, square root of the denominator, in brackets, squared. Now, c over 1, I'm going to show a little bit more than I do here. So I want this to be over 4a. That means I need to multiply the denominator by 4a and the numerator by 4a. So this is going to become 4ac over 4a minus b squared over 4a. Let's gather these two together. So that's all I'm going to do next. X plus b over 2a. That's still squared. And now, because these are a common denominator, I'm going to make it one single fraction. 4ac minus b squared over 4a. And that equals 0. Okay, so I'm going to take this term and move it to the right. Well, that's going to leave us with a, x plus b over 2a. That's going to be all squared. So when this goes to the other side, it's negative 4ac minus b squared over 4a, like so. A negative with a fraction can either go to the denominator or it can go to the numerator, but it has to go through the whole numerator. So I'm just going to change the appearance of this a little bit. And again, I'm trying to mold the formula. If you remember, I'm trying to show you where this formula came. Negative b plus or minus square root b squared minus 4ac over 2a. So this should be kind of like I'm got some Play-Doh here, and I'm trying to mold what I'm doing here and turn it into this. You can kind of see glimpses of it starting to appear here. So the first thing I'm going to do then, at this point now, is take this negative and distribute it through the numerator. Now it doesn't go to both, it only goes to either the numerator or denominator. So I'm going to put it through the numerator. When I do that, oops, I'm going to leave this side over here alone. X plus b over 2a, all squared. This will become negative 4ac, and this negative will switch this to a positive. I'm just going to switch the order of them into this. That's what would happen if the negative went through there. Now, the reason I did that too, again, I'm trying to mold this formula. So it's getting, as I said, glimpses of it. Well, the next thing I've got to do is get rid of the a. Remember, if it was a 2 in front or a 3 in front, you just multiply by 1 over that value. So I'm going to multiply by 1 over a. multiply this side by 1 over a. That would get rid of that and leave us with x plus b over 2a all squared. And now I've got b squared minus 4ac all over 4a squared. The next step in our process has always then been take the square root of both sides. X plus b over 2a. This is plus or minus. The numerator is not a perfect square, so I'm going to leave it underneath the square root sign. However, 4a squared is something that I could take the square root of. It's a perfect square. It would be 2a. Well, we're almost done. And we're starting to look like our formula. Hopefully you can see that anyway. I'm going to move this to the other side. X equals negative b over 2a plus or minus the square root of b squared subtract 4ac all divided by 2a. These have a common denominator, so that'll let me combine them together into, presto, what is known as the quadratic formula. Just put one big line over all of that. And now, what that allows you to do is get the formula, to do all of the work for you. And if you have any quadratic written in this form, ax squared plus bx plus c equals 0, you no longer have to go through all the steps of completing the square. All you need to do is fill in the a, the b, and the c into this formula. Because regardless of what you put in here for a, b, and c, that's the way variables work. I just worked it out generically for any number, so using letters instead, and it showed me that regardless of what the numbers are, without doing all of that work, all I got to do is fill them in here, and I'll get the answers. So you don't actually have to do the steps of completing the square. The formula has done that for you when it was derived. Now, once students learn this formula, I would really discourage you from solving quadratic equations by completing the square, just because this formula is so much more efficient and less likely for you to make a mistake. And it's not because I don't think you should be able to or can manage it, but it's that whole work smart, not hard. All this work here that we did, the quadratic formula will do it all for you if you just fill in the numbers. So if we can avoid doing all of this work and simply arrive at these answers, well, certainly that's what we would like to do. All right, so let me show you what that means and how to put this all into play. So here's our first example. It says find the exact roots. So there's the indicator. It doesn't want me to find the square root and put it in my calculator. If I look at this quadratic, it's already set equal to 0, so that a is the number in front. It's a 2. B is negative 5. And c is 4. And now my formula, which is, I'll just jot it down here, x is negative b plus or minus the square root of b squared subtract 4ac, all of that divided by twice a. So I'm going to fill these numbers into the formula. So this one is negative b. Well, b is a negative 5. So negative 5 plus or minus b squared minus 4a c over twice a. And now it's just a matter of doing some basic computation. So negative 5, we wouldn't leave it like that. That's 5. Plus or minus square root. This is 25. Take away let's make one little change here. I don't want my first one to throw you for a loop here. Let's make this a negative 4. I know it's not, but we're going to just for, you'll see why in a minute. Negative 4. This is negative 4. That'll make this now a positive 32, and this will be 25, which will be 57. All of that over 4. And because this isn't a perfect square, you'd be done. There's your answers. x equals 5 plus or minus square root 57 over 4. Now I'm just going to show you and say, well, why did you change that? What was the difference? If I hadn't made that change, this is what would have happened. X would have been 5 plus or minus. So imagine this was now a positive. So then it would have been here, instead of what I ended up with, it would have been 25 take away 32. And I would have got a negative 17. Well, I know your work with radicals is a limit, but I hope that you realize this is impossible. You can't do that, which this is what can happen with quadratics. I just didn't want it to happen in our very first example. So that was kind of a typo on my part. The square root of negative 17, all this indicates to us is that this quadratic has no solutions. So that is what happens when you get a negative underneath the square root sign, because we can't take square roots of negative values. However, if I make that one little change here to a minus, then all is good, and we get 5 plus or minus square root 57 over 4. All right, here's another quadratic. This one's all set up for us. Give it a quick look and say, well, this factor, 2 multiplied by negative 5 is a negative 10. I want to multiply to get negative 10, and the two numbers that I multiply give me a positive 8. Not going to happen. The only way to multiply to get 10 is 10 and 1, 5 and 2. They're not going to anyway give you an 8. Exact value. That means don't put this in your calculator and get decimals. X equals negative b. So b is 8, so there's negative b. Plus or minus. X equals negative b plus or minus square root. Now students will often in the beginning say, do I have to write the formula out? And my answer is always, not if you know it, but most of you probably don't know the formula. So I would encourage you to, at the top of every question, write out the formula. Do it 15, 20 times, then you'll know the formula. It's the students who say, I don't want to write the formula out, are the same ones that screw it up on the test, or when we try to see if you really know it, because they haven't put the effort into making sure that it's been ingrained in their brain. And by writing that out and saying it as you're writing it, 15, 20, 30, 40, however many times it takes, you will know the formula. So at this point, I highly, highly recommend you write out the formula. So there's negative b plus or minus square root. So b is a positive 8. I'm just going to kind of square it as I go. So there's b squared. Subtract 4 multiplied by a multiplied by c. All of this gets divided by twice the value of a. Now we just tidy this up. We got negative 8 plus or minus square root. So this is 64. That's a negative, so that's going to become plus. This will be 40. 64 and 40 is 104. Divided by 2 times 2 is 4. X equals negative 8 plus or minus. Now, at this point, because we haven't done our unit on radicals yet, and many students from grade 10 are really rusty on their radical work, they may not recall how to simplify this radical. I'm going to do it, but at this point in the course, I probably wouldn't penalize you for not reducing the radical any further. But the square root of 104 will reduce by splitting it into a perfect square that's a factor of it. I'll show you what I mean by that. I got to figure out what it is here first. So if I take 104, I try dividing it by 4. Yes, so 104 is 4 times 26. So if that was underneath the square root sign, I could take the square root of 4 and it would come out front and become a coefficient. And this would be 2 radical 26 over 4. And then I'd say, hey, I can divide everything here by 2. So the whole numerator. Now this only works, you have to be able to divide every one of these by some coefficient. And this would be the reduced version of it. Negative 4 plus or minus radical 26 over 2. Now, the reason I'm showing you this is because if you look in the back of a math textbook or any kind of an answer key, this is what they're going to have there. Sometimes students will do out their work and get to here, flip to the back of the book, check their answer key, and see this, well, instinctively, if they don't understand the whole bit about simplifying, they may think they have no idea what they're doing because their answer looks nothing like the answer in the back. But if you look at this answer, it is the same as this answer. This is just the reduced version of it. So at this, as I said, based on our limited knowledge of radicals right now, don't worry too much about reducing this. But having said that, don't necessarily look at an answer key and think that you're doing it right without saying, oh, maybe there was just a way that what I have could have reduced to that. And in an ideal world, you'll understand what I just showed you and you'll be able to reduce these radicals on your own. All right, let's have a look at one more of these. Here's another quadratic. So this one says round your solutions to the nearest hundredth. This is telling you now to put it in your calculator. So we're going to, when we get into our formula, put this into our calculator and get the answers. So I'm going to, same thing, x equals negative b plus or minus. So I'll model what you folks should be doing right now. Write out the formula and then fill in the formula below it. So x equals negative b. Well, b is a positive 4, so negative of that would be a negative. Square root. B squared would be 16. 4 times a, which is 3, times c, which is negative 8. Everything gets divided by twice the value of a, which is 3. X equals negative 4 plus or minus 16. This is negative, negative, so that's going to be a positive when you multiply them. 12 times 8 is 96. Add 16 is 112. All right, 96. Yep, 112. So the square root of 112. And then the denominator will be 6. Now, because it said nearest hundredth, didn't say exact, it wants us to actually take our calculators out. X equals negative 4 plus or minus. It wants you to figure out what that is to the nearest hundredth, 2 decimal places. I'll take my calculator out here. The square root of 112 is 10.58. So I'm going to put that in here. Divided by 6. And now I'm going to get the 2 possible answers. I'm going to go negative 4. Negative 4 plus 10.58. Make sure you hit equals, which is 6.58, and then divide that by 6. And that gives me 1.096. So when I round that to the nearest tenth, it's going to be 1.10. What you'll usually see when they're not exact anymore, you put a dot above your equal sign. Or some books will use kind of a swirled equal sign like so. So x equals approximately, now I'll go negative 4. And I'm going to subtract 10.58, get my answer, which is negative 14.58, and then divide that answer by 6, and I'll get negative 2.43. So there are the 2 answers approximated to the nearest hundredth. So that's why so how do you know when to do that and when not to do it? If it tells you to go to a certain decimal place, then you're going to put it in your calculator and get the decimal values. If it doesn't, it's just as easy to leave it as an exact radical. Now, if it says exact, that means do not take the square root of it. So that's kind of in the semantics of how the questions are worded. Now, let's quickly look at this one. 6x squared, take away 7x, take away 3 equals 0. So there's A, B, and C. X equals, now I'm going to not write the formula because I know it, but you folks should probably still be writing the formula out. So negative B, B is a negative 7, so negative 7 is plus 7, plus or minus. B squared, so whether it's 7 or minus 7, when you square it, you're going to get a 49. Plus or minus 4 multiplied by A multiplied by C. everything divided by twice the a value. So x is equal to 7 plus or minus. So this is, what am I doing here? That's not plus or minus. This should just be minus. This is where I don't have you guys sitting in front of me to make my corrections. That should be b squared subtract 4ac. So now it's negative negative. This is 24 multiplied by 3, which would be 72, and 49 is 121 over 12. Okay, so here is, you notice up here it said connecting the quadratic formula to factoring. This is the dead giveaway right here. 121 is a perfect square. If this number underneath here is ever a perfect square, that tells you, and again, you wouldn't go back and do it, but it tells you that this would factor. Now I'll finish it because I'm already almost at the answers. So x equals 7 plus or minus the square root of 121 is 11 over 12, which will give me 7 plus 11, that's 18 over 12. And 18 over 12 reduces to 3 over 2. Or, if I went 7, take away 11, that would be negative 4 over 12, which would reduce to negative 1/3. So we get the two answers, 3 over 2 or negative 1/3. I could have in the beginning, right away, went to factoring if I had noticed it. Here it is by factoring. 6 multiplied by negative 3 is negative 18. I want to get a negative 7. I could use a negative 9 and a plus 2. 6x subtract 9, 6x plus 2 equals 0. Divide this one by 3. That'll give me 2x, take away 3. Divide this one by 2. That will give me 3x plus 1. This is multiplied by this, and the answer is 0. That could only happen if this bracket was 0, which of course would only happen if x was 3 over 2. And this bracket could only ever be 0 if x was negative 1/3. Same two answers that I just got by using the quadratic formula. So as we alluded to this earlier when we did the completing the square, there's the giveaway that this is factorable. Okay, so that is a good look at how to use the quadratic formula. This is just a quick example. So this was a student. They said this was their work for the quadratic formula. It says she used the formula, got these answers. Could Sandy use factoring to verify her solution? Explain how you know. And I can look at this quickly and within 5 seconds say, yep, could have factored. Say, how do you know so quick? Look right here. That's a perfect square. You can tell by the answers as well. They're these nice fractions. So here the answer would be an yes, because that's how I know. Perfect square underneath the part of the formula, the b squared minus 4ac. We'll talk more about that a little bit later on. We'll get into something called nature of roots, and we'll allude to that a bit more. So as a wrap up, I have a quadratic, and we're going to solve this quadratic using 3 different strategies. Alright, so we're just going to take this last one and show you how I could solve this quadratic, and I'm going to solve it using the 3 strategies that you have been shown. I'm not saying one's better than the other, I just want you to be able to understand how each of these strategies unfold. Okay, so let's take this quadratic, 3x squared, subtract 13x, subtract 30, and we make it equal to 0. So I'm going to do it by factoring. 3 multiplied by negative 30 is negative 90. I need two numbers that multiply to give negative 90, and when I add them, I get negative 13. And those two numbers are 18 and 5, I believe. Yes, 18 and 5 will work. So it's a hard trinomial, so I'm going to go 3x, take away 18, 3x plus 5 equals 0. Negative 18 times 5 is your negative 90. Add those, you get your minus 13. The first bracket is divisible by 3. So I divide these by 3, and I will get x subtract 6, 3x plus 5 equals 0. So my two answers are 6 or negative 5/3. 99% of the time, if you can solve it by factoring, that will be the quickest way to get to your solutions. However, now that you've got the quadratic formula at your disposal, again, this one, it can get, as you've seen, it can get pretty involved and complicated, especially with fractions coming into the mix. But I would tell students use about the 10 to 15 second rule. If you look at a quadratic and within the first 10 to 15 seconds you do not see the factors of it, don't sit there for 15 minutes trying to see if it'll factor. Put it in the formula. It'll give you the answers every single time, even if it would have factored and you couldn't have figured out the factors. Okay, number 2, let's go vertex form. So vertex form, I'll switch colors here and do this one in red. Okay, so this time you got to factor out the 3, x squared. Doesn't go evenly into the middle one, so it's 13 over 3x plus, we've got to subtract 30 here, and equals 0 over there. Half of 13 over 3 is 13 over 6. Square that, we're going to get 169 over 36. That has to get multiplied by 3. Well, 169 over 36, when you multiply by 3 over 1, this 3 will go into this and give you a 12. So it's 169 over 12. 169 over 12, that's the reduced version of it. And that will, when I put it, so I'm going to subtract 169 over 12. Now I'm going to, right here, so it's 3, square root of the first, sine of the middle. This one's a perfect square, 13 over 6, squared. Now 30 over 1, when you put it over 12, so 30 times 12 is 360. So I'm going to have here, maybe that reduced anyway, it's okay, we'll find it here. So I'm going to have, what did I say, 360, 529? Double check my math here. Yeah, so it's going to be 529 over 12 equals 0. So right away you can see we're getting into stuff way more complicated than this. So certainly factoring would have been the strategy of our choice. Alright, so now we're going to isolate our bracket here. Take away 13 over 6 squared equals 529 over 12. Divide both sides by 3, which can be also accomplished by multiplying by 1/3. Multiply both sides by 1/3. Those will get rid of each other. So now it's 529 over 36. Take the square root of both sides. 529 is a perfect square, in case you're wondering, as is 36. So this gives us x subtract 13 over 6 here again. So this is equal to, square root of 529. Remember, this is always going to have to be plus or minus. Would be 23. Square root of 36 is 6. X is equal to 13 over 6 plus or minus 23 over 6. X would equal 13 plus 23 is 39 over 6. Sorry, 36 over 6, which is equal to 6. Good sign, that's one of my answers. And X could equal 13 subtract 23, which would be negative 10 over 6, and that would reduce, if I divide them both by 2, would be negative 5/3. So fortunately, I have the same two solutions. However, you'd be hard-pressed to make an argument that anyone would want to do it using the strategy on the right. Now, strangely enough, for whatever reason, I don't know if it's because students think that completing the square is some kind of a savior or something, but they'll try to do it using this strategy when they could have used this strategy instead. I would probably at this point tell you that I would never use this strategy because the quadratic formula does all this for you anyway. So, I mean, the only time I would get into this if I was told I had to do it that way. Otherwise, I'd either factor, and if it didn't factor or I couldn't see the factors, I would go to this third strategy, which is completing the square. So here it would be with that third strategy of the quadratic formula. X equals negative b, so negative, 3x squared, subtract 13x, subtract 30 equals 0. So negative b would actually be positive 13, plus or minus the square root, so b, which is negative 13 squared, is 169. Subtract 4, multiplied by the a value, multiplied by the c value. Everything then we could divide it by twice the a value. So x would equal 13 plus or minus square root. So this is 169, negative, negative. This is 360, which would give me 529. Oops, 9, not 6. 529 divided by 6. X equals 13 plus or minus, this is now 23 over 6. Now just to show you, oh, it's gone. I had a technical issue in my disappeared, but if you remember when we did completing the square, this is where we ended up with. We ended up with, at the very end, it was x equals 13 over 6 plus or minus 23 over 6, which gave us the same two answers. 13 plus 23 was 36 over 6, which is 6, or the other answer, 13 subtract 23, which is negative 10 over 6, reduced to negative 5 over 8. So that one, it's not much, worse. Some might argue I like that better than factoring. Now, I don't want you to automatically go to this strategy. It is certainly kind of a foolproof way to solve any quadratic. You can use the formula. Now students will say, well, I'm not very good at factoring, so I'm going to use the formula. This is what I'll tell those students. You need to get better at factoring, or you're not going to be in pre-calc a whole lot longer. You have to be able to factor if you're going to navigate your way through these pre-calculus courses. So the more practice you get at it, the better off it's going to be for you. So this now gives us another strategy, two I guess, to use to solve quadratics. And this strategy is used, it can be used if they factor, but it absolutely must be used when they don't factor. So you've got to either get really good at the quadratic formula, which I recommend, and also be familiar with where this quadratic formula came from, which was by the method of completing the square. All right, so thanks for watching. Again, as always, if you have any issues, reach out and we'll try and get you pointed in the right direction. There will be a set of practice questions in your class notebook that you can use to reinforce and make sure you understand this material. Best of luck.